resistors or resistors in series. So for this, we have to consider three resistors of resistances R1, R2 and R3 combined in a way that they have a series combination. So what do you mean by series combination? That is, as I've told you, when you connect three resistors in series, that means that one end goes into exactly the opposite end of the other resistor. That is, if you consider this as left and right or plus or minus, then the plus minus then goes plus minus and then goes plus minus. So it's just like standing in a row, holding the left hand of one person goes into the right hand of the other person, and the second person holds the left hand of the second person is held by the right hand of the third person. So you are standing in a row holding each other's hand. So it is just like this. You have the resistors in series. Now, in order, this is the circuit diagram for considering the resistors in series. So we are more interested in Ohm's law. That is, Ohm's law is a relation that connects the current flowing through a circuit and the potential difference across the circuit. So we need to know certain basic things. That is, while drawing the circuit diagram, what all we need to consider. So let us have a look at the circuit diagram. We have three resistors of resistances R1, R2 and R3. Suppose all three are different resistances, have different resistances. So you can think of a wire or which is connected with a bulb, which is also connected in series with another device, say some other bulb of different resistance. So you can think of three different bulbs of a different wattage, or you can also think of three different wires being connected one after the other. So suppose in that case, if you have one wire of particular length, another wire of particular length, another wire of particular length. Why I say wire of different length is due to the fact that we know that R is equal to rho L by A, or R, resistance of a wire, is directly proportional to its length and inversely proportional to its area of cross section. You can also think of three wires having different area of cross section, different thicknesses also connected in series, such as that you have one wire connected to the other end is connected to the beginning end of the other wire, and so on, just like this, as a longer wire. Okay, so in this case, R is equal to rho L by A. So you have R directly proportional to L. Now we don't have to consider that. So we have three wires of different length, or three devices or three bulbs of different resistances being connected like this. Now we should have obviously cell or a combination of cells. So we have connected two cells here. Here also they are in series, because negative of the first cell goes into the positive of the second cell, and so on. You can think of any number of cells here. I can include another cell. I can also include another cell. Any number of cells I can include. Okay, only thing is that negative of one has to go into the positive of the other cell. Okay, now we have a key here, and key is in closed circuit. That means it is in the on position. So it will send the current. Now what is the direction of current? Current is from, conventional current is from positive to negative. Now we have an ammeter. What is the role of an ammeter? An ammeter is to measure the current in the circuit. Measure current. It's a device used to measure the current in the circuit, and it is connected in series. Okay, see this, my plus minus, it goes on. You have at the end negative. That is why it is connected to the positive terminal of the ammeter. So I have already posted a video which shows the experiment conducted based on Ohm's law. In that you can see the connection, how the connection is made. Here also it is connected in series. Now we have another device which is known as a voltmeter. See, this is a voltmeter. It is represented like this. Voltmeter is used to measure potential difference across any part of the circuit. Here we want to find out the potential difference across the series combination. That's why we have connected it across R1, R2, R3 whole as a whole. Suppose if you want to find out the potential difference along R1 alone, then you have to connect it here. If you want to find it across R2 alone, then you have to connect it in between across R2. If you want to find it across R3, then you have to connect. But now in this experiment, we are interested in finding out the potential difference across the series combination of R1, R2 and R3. So for that purpose, I have connected it starting from R1 till the final end of R3. So it is used to measure the potential difference across. So I told you measure current through, you use the technical terms current through and potential difference across. These are the technical terms you should remember, because current is always through the circuit. Potential difference is just like a bridge, like it is across two ends. Okay, so potential difference across a component. Okay, so how is a voltmeter connected? See, it is connected parallel. How to check for a parallel connection? Parallel connection will always be positive to positive and negative to negative. See, it is from positive end of the cell, it is goes into the positive end of the voltmeter. Negative end of the cell, it goes into the negative end of the voltmeter. So this is how the connection is made. Now, the most important or the striking feature of a series combination. The first thing you have to consider is that, first thing you need to consider, or the first point you have to consider, is that current I flowing is same through all components. All components means all, whatever component you have in this circuit, all components. See, this is one component, this is one component, this is another component. So we are interested in the current flowing through all the resistors. So current flowing, see, I have marked it as blue because it is all same. The current flowing through it is same. Okay, current I flowing is same through all components. But what about potential difference? Potential difference V is different or varies. Okay, so that is the idea behind our derivation. We have to find out an expression for the total resistance. What happens when three resistors are combined together? So this is the idea. Current I is same and potential difference is different or varies. Now let us write the expression in terms of the varying quantity. The varying quantity here is the potential difference. So let us start with the potential difference. Now, as I told you, the potential difference is different, but it gives you the total potential difference. That is, the potential difference across R1 is V1, potential difference across R2 is V2, potential difference across R3 is V3. Then the total potential difference across the combination V is equal to V1 plus V2 plus V3. Got it? So it is V1 plus V2 plus V3. Now let us write what is V1. V1 will be I into R1. As per Ohm's law, we know that potential difference is given by the product of the current and the resistance. So I is same, or it is I into R1. V2 is equal to I into R2. V3 is equal to I into R3. Okay, now as per this equation, we have I into R1 plus I into R2 plus I into R3. What this will give you on the left hand side? In the left hand side, you will get the total potential difference. Total potential difference, let us name it as, it is the current multiplied by the total resistance across the combination. So let us name the total resistance across the combination as RS. R subscript S, because it is resistance in series, I into RS. Now I can be taken out, R1 plus R2 plus R3. Close the bracket, I into RS. I gets cancelled, and what do you get as RS? RS is equal to R1 plus R2 plus R3. So for a combination of resistors in series connection, the total resistance, or you call it as RS, is known as equivalent resistance, or it is also known as effective resistance. Effective resistance is the combined effect of these resistances. You get it as sum of individual resistances. That is, you can think of any number of resistors in series connection. The final effective resistance, or the combined effect of these three or more, or any number of resistors, will be sum of individual resistances. So RS will be equal to R1 plus R2 plus R3, and so on. You can go on with any number of resistances. It will be the sum of individual resistances. Now we have to note certain points here. In a series combination of resistances, you have the final resistance of the effective resistance or equivalent resistance, RS, will always be greater than the largest of the resistances. What does that mean? Say for example, if you have 1 ohm, 2 ohm, 3 ohm connected in series, if you have three resistors, 1 ohm, 2 ohm and 3 ohm connected in series, then Rs will be equal to R1 plus R2 plus R3, 1 plus 2 plus 3, it will be 6 ohm. When you compare 6 ohm with 1, 2 and 3, it is greater than the largest of the value. So that is one thing you have to note. The effective resistance or the equivalent resistance will be greater than the largest of all resistances. So when you add resistors in series, you will get a value anyway greater than the largest of the values. Whatever, how much ever you resistors, values of resistances you can combine, it will be greater than the largest of value. Another thing you have to notice is that the combination series combination of resistors, resistance increases, Rs increases compared to individual resistances. That means when resistance increases, current decreases. Current decreases. What does that mean? If you go for a series combination of resistances R1, R2 and R3, due to the combined effect of these resistances in series connection, the effective resistance increases. That means the current through the circuit reduces. So if you want to reduce the current flow in a particular circuit, you can go for a series combination. Now if you have other identical resistors, identical resistors identical resistors in the sense that all equal resistances. Okay, that means if R1 is equal to R2 is equal to R3, then it can be replaced by, we don't want R1 to R1, R2, R3 because they are not separate. Now they are all having same value. Then let this be equal to R. Then what will be the series combination? R plus R plus R. R1 plus R2 plus R3, it is 3R. So if you have 3 resistors, it will be 3R. If you have 5 resistances, you have 5 into R and so on. So if you have n resistors which are equal or identical, identical means having same value of resistances, then Rs is equal to simply n into R. Suppose for example, R is equal to 2 ohm and we have 2 ohm. We have 5 number of resistors, each of 2 ohm, then Rs is equal to 5 into 2, 10 ohm. So you can simply go for this expression. Identical resistors means equal resistances. R1 equal to R2 is equal to R3 equal to R. Rs is equal to R1 plus R2 plus R3, which is equal to 3R. So n resistors which are identical, Rs is equal to n into R. So this is another point we have to note in a combination of series resistors. And the thing is that potential difference is different and the current flowing through it is same, and the combination for, you can go for any number of combination of series resistances and you can apply the formula and finally find